We now discuss an important theorem that relates the work done on an object by a net force to the object's kinetic energy, a quantity that will be defined momentarily. We start by imagining the work done when a constant net force F acts on an object that moves through a distance s. We write this as W equals the sum of the forces times s, and through Newton's second law equals ma times s. We know that a net force acting on an object will cause it to accelerate, which means that, since the force is constant, the acceleration is constant, and we can apply the equations of kinematics to find the change in velocity of the object. Since we know the acceleration a and the displacement s, we can use the equation v final squared equals v0 squared plus 2as, where we use s rather than the usual x since our displacement is s. This means that we can substitute for as in our expression for the work, since as equals 1/2 v final squared minus 1/2 v0 squared, and the work can be written as W equals 1/2 mv final squared minus 1/2 mv0 squared. The kinetic energy of an object of mass m moving with a speed v is defined as Ke equals 1/2 mv squared. It has the same unit as the work, namely the joule. The work energy theorem states that the work done on an object is equal to the change in the object's kinetic energy, or W equals kinetic energy final minus kinetic energy 0, which equals 1/2 mv final squared minus 1/2 v0 squared. Consider the following example. A force of 120 newtons acts on an object through a distance of 3.20 meters. If the object starts from rest, how much kinetic energy does it have after the force acts on it? To answer this, we first apply the definition of work to calculate the work done on the object. This is given by W equals F times S, which equals 120 newtons times 3.20 meters, which equals 384 joules. Since the object started from rest, meaning V0 equals 0, and therefore the initial kinetic energy is 0, the kinetic energy of the object after the force acts on it through a distance of 3.20 meters is also 384 joules. If the object has a mass of 0.150 kilograms, what is the object's final speed after the force acts on it? Since we know the value of the final kinetic energy, we set that value equal to 1/2 mv final squared, so that 1/2 mv final squared equals 384 joules. Solving for the speed, we have v final equals 71.6 meters per second. In summary, the kinetic energy is defined as Ke equals 1/2 mv squared. The work energy theorem states that when a net external force acts on an object, the kinetic energy changes from its initial value of Ke0 to its final value of Ke final, the difference between the two values being the work. Mathematically, we express this as the work equals Ke final minus Ke0, which equals 1/2 mv final squared minus 1/2 mv0 squared.